Let's see if we can use the information that we're given about the maximum and minimums to draw a sketch of a graph that we think could represent our function. So here we go. Number 3, sketch the graph of a function f that is continuous. That means that there's no jumps, there's no breaks. You don't have to pick up your pen as you draw from the left to the right of the full graph. That is continuous on 1, 5 and has the given properties: an absolute minimum of 1, absolute maximum at 5, local minimum at 2, and local maximum at 2 and local minimum at 4. So let's see if we can first label this. So let's see here. I need 1, 2, 3, 4, 5. Here we go. So sketch the graph. Continuous on 1 to 5. We got that part. Now notice it doesn't say anything about y. So we're just going to leave this without a scale and we'll put our values wherever we think they should go. Absolute minimum at 1. So that means that 1 is going to be the x with the lowest value. So I put a dot right there. I could have moved it here. I could have moved it there. I could have put it way down here. It doesn't matter. I'm going to build the rest of the function from where I set this. So absolute minimum at 1. Got it. Absolute maximum at 5. I'm going to give myself some space. So I'm going to put this up here. Let's see what else it says. A local maximum at 2. So I need it to be a local maximum. So it's going to need to be above this one, below this one. So how about right here? And a local minimum at 4 right here. So I need a local minimum. So it just needs to curve down. There we go. So let's connect our dots. There we go. That was supposed to be the end. Whoops, didn't mean to erase the whole thing. There. We have an absolute minimum at 1. We have an absolute maximum at 5. We have a local maximum at 2 and a local minimum at 4. I think we got it. All right, let's try number 4. Sketch a graph and use the graph to find the absolute and local maximum and minimum values. So now we have an equation. I'm going to rewrite this equation. We could rewrite this as y equals negative 3x, and this was a positive 8, so plus 8. If we do that, we can see our m is negative 3, or negative 3 over 1, and then our y-intercept, so our b value, is 8. So that means that we can start our graph at 8. So I need to get up to 8. 1, 2, 3, 4, 5, 6, 7, 8. There we go. We can start our graph at 8. And to get to our next point, we go down 3. So down 1, 2, 3, and over 1. And if we need another point, we can go down 3 more. 1, 2, 3, and over 1. There we go. And we can connect our dots. There we go. And we can draw our line. Now we see right here it's saying x is greater than 1. So that means we're not considering our entire graph here. We're considering x is greater than or equal to. See that little line underneath? Greater than or equal to 1. So here's 1. So if I need x greater than or equal to 1, we need to think of it as if there was a division of our graph, and every x greater than or equal to 1 would be over here. So now let's see if we can answer the question. It's asking us to sketch a graph and use the graph to find the local max and minimum. So let's see what we can do. Well, the absolute max right here would be when x is 1, because that's the highest, but now it's going to be an endpoint because of our condition on our domain right here. So it's not going to be a local max, but it would be an absolute max. And because it says greater than or equal to, greater than means that it's going to keep going. So there is no min. There's no local min, there's no absolute min, so there's no local or absolute min. What about a local max? Well, remember, it can't have a local at an endpoint, local max or local min. So 1 right here is going to be the endpoint. So the only thing it can be is the absolute. So it looks like we have only an absolute max of 1 for our linear equation for this one.